Hey everybody, it's Mr. Enyart. Welcome to Lesson 3, Eureka Math or Engage New York. Today we're going to focus on ratios and tape diagrams. So how do these models help us? So far we've seen quite a bit of other tools, but these ones really let us use these ratios and you find something called equivalent ratios. So equivalent ratios is our other focus for this lesson, and we're going to find them by using a tape diagram. In order to do that, we need to understand what a tape diagram is. So here we have Sam's books and Jane's books, and this story might read something like this. Sam and Jane were both reading books over the summer, and for every 4 books that Sam read, Jane read 2. So our ratio would look something like this. Might have a ratio of 4 to 2. And obviously that would be Sam to Jane's and how many books they read. So here this model shows 1, 2, 3, 4 to 1, 2. And you'll notice each part is the exact same size as the other. So these 2 parts are the exact same amount as these 2 parts, which makes sense because right now each box represents just 1 book. Sam read 1 here, 1 here, 1 here, 1 here. But what if Sam read more than 4 books? What if he read, let's say, a total of, I don't know, 8 books? If he read 8 books and the ratio is going to stay at 4 to 2, how can this tape diagram help? Well, again, right now, it's just showing 1, 1, 1, 1, 1, 1. Gives you a total of 6 books, and that's why here the ratio of 4 to 2 is 6 total books. But what if he read, just Sam, a total of 8 books? Well, I want to keep the objects the same, because they're still books, it's just the amount that changes. So what I need to do is I need to get rid of the 1s, and I'm going to replace them with something that gives me a total of, for Sam, 8. So how do I make 4 equal pieces equal 8? Well, what's 8 divided by 4? That's right, 2. So each box represents 2 books, which means the same thing for Jane. And the question might be, how many books did Jane read if Sam read 8? Well, if each of these is 2, because they're all the same size, right? Since the boxes are the same size, that means they're going to be worth the same amount. So that would give me, for Jane, a total of 4 books. And now we could rewrite that ratio, 8 to 4, and that sticks with the exact same 4 to 2. They work because 4 times 2 is 8, and 2 times 2 is 4. So here we have a new tape diagram, but notice there's no labels anywhere. I don't have a title. All you can see is my tape diagram. I've just got my 2 figures with a certain number of groups in each one, and each group looks the same. So what I want you to do is figure out this problem. It says Tom bought a large bag of Starbucks candy. He noticed there were 2 pinks for every 3 yellows. Write a ratio, the ratio, for pink to yellow candies and draw a tape diagram. Well, as you can see, I already draw the tape diagram for you, but go ahead and pause the video right now and see if you can write that ratio. So the ratio for this would clearly be 2 dot dot 3, and that would be 2 to 3 pink to yellow candy. So there's more yellows than there are pink. But remember, he bought a big bag. So at this point, I can go and label my tape diagram. The top part with the 2, so this one right here, this would be our pink. And I know I'm writing in yellow, but it's still, you get the idea. These 3 down here would represent the yellows. And again, what I want to notice is that gives me a total of how many candies? That is correct. It gives me 5 total candies. And because I have 2 there, each of these represents 1. So that's the way it's drawn right now. To equal a total of 5, each one has to represent 1. But what if my total number of candies was a whole lot more than that? What if my total number of candies was, let's say, 50? Could each box represent 1 and it be 50? No. So I'd have to change that. So how could I break down 50 total candies into groups of 2 and 3, or in this situation, into 5 equal groups? Because each size is the same. So really, I'm looking at this problem. What is 50 divided by 5? Go ahead and pause the video and figure out. You are correct. It is 10. So that would mean that there were 20 pinks and 30 yellows. And I can use these tape diagrams for all problems like this. Okay, so I'm not going to read this problem to you out loud yet. What I do want you to do is to go ahead and read it yourself and then pause the video. Well, pause the video first. Read it yourself and see if you can solve it. And then don't play the video until you've tried 1 or 2 options. All right, now that you've tried it, let's look at the different elements of this problem and how we can use our ratio knowledge and common sense to solve it. So John and Mary were marine biologists. They measured the mass of different sea animals to see if the animals were getting ready or getting enough food. John always measured 3 animals for every 2 animals that Mary weighed. So I'm just going to write that ratio of 3 to 2. Hopefully maybe you started there, maybe you didn't. And then the question asks, how many pounds of tuna did Mary measure the day that John measured 900 pounds of tuna? Well, I'm not sure, but I know that they do have a 3 to 2 ratio on how much John measures to how much Mary measures. And I do know that 900 pounds was how much John did. So I can use a tape diagram. And so what I'm going to do is I'm just going to draw my own. And I'm going to draw and then divide it into 3 sections. And then I'm going to do the same thing with the bottom, but only 2 sections. And that shows that if each of these were 1, that would give me a total of 5. And that would give John 3 and Mary 2. Problem is I don't have 2s or 1s or 5. I got 900 pounds, and that's John. So that means the total amount he weighed, as it says in the problem, is 900 pounds. And I can see it's been broken into 3 equal parts. So if it was broken into these 3 equal parts, right here, here, and here, for John, 900 broken into 1, 2, 3. I can see right away, well, this is just 9 divided by 3, which is 3, and then 2 zeros. So each one of these would have to be, that's right, have to be 300. So I'm just going to erase the 1s, and now I'm going to write my 300 in here. Now remember, each of these were exactly the same size, which means these will also be 300 because it was 5 equal parts. And if that's the case, I can erase my 1s out of there and write 300 in here, 300 in here. And I can see that, I'll make that a little bit better, I can see that Mary would have gone 600. She would have measured 600 pounds, which would give us a total of 900 plus 600. That's going to be 1,500 pounds now. So they've measured 1,500 tuna, or 1,500 pounds of tuna. John would have measured 900 pounds of that, Mary 600 pounds of that. And that's because of the 3 to 2 ratio. And these are 3 good examples of how tape diagrams can help with ratios and equivalent ratios. We want to remember equivalent.